Okay, so for this deep dive, you dropped a really fascinating question on us.
Oh, yeah.
How on earth do you even start estimating the number of Uber drivers in, like, a massive city? Bangalore, for example.
Oh, right. That one. Yeah, it's a classic estimation problem, isn't it? And the source material you provided, it actually walks through one specific way to try and tackle that.
Exactly. And that's what we want to unpack here, right? Not necessarily saying this is the number, but understanding the logic in this specific source, how they broke it down.
Precisely. It's all about the methodology, taking a huge, messy question and applying some structure, some assumptions to get to an answer.
So let's walk through their steps. They set the stage first. We're talking ride hailing, so cabs, autos, bikes.
And crucially, pre-COVID conditions,
Mm-hmm.
normal commute patterns.
That's a key point.
Yeah.
And their big idea is to focus on peak hours, right? Like the morning rush.
Yeah, they figure if you can estimate the drivers needed for the busiest time, say 8 a.m. to 11 a.m., that gives a decent baseline.
Makes sense. If you can cover the peak, you can probably cover the rest. So it's that 3-hour window they focus on.
Okay, so where do they begin? The source starts with a big number, Bangalore's population, around 13 million people.
13 million. Wow. Okay, but not everyone's a potential customer, obviously.
Obviously not. So first filter, age. They zero in on people aged 20 to 50. The assumption being that's the prime working age group likely using these services for commuting.
Right, the commuters. And how many people is that, roughly?
Well, the source uses average life expectancy, say 80 years, to estimate this slice. It comes out to about 4.8 million, which they kind of round up to 5 million for easier calculation.
Okay, 5 million potential commuters in the right age range. What's next? You need the tech, right?
Exactly. Can't hail an Uber without a smartphone and internet. That's the second filter.
And they make an assumption about how many of those 5 million actually have that tech.
They do. They assume pretty high penetration, actually, 80% for this 2050 age group. They figure this demographic is, generally tech savvy.
80%. Okay, so 80% of 5 million. That brings the number down to 4 million.
4 million people. Right age, got the tech.
Yeah.
But can they afford it? Especially for regular commuting.
Ah, yes. The affordability question. That's going to be a big filter.
It is. This is where the source makes quite a significant cut. They estimate that only about 25% of those 4 million can actually afford cab services regularly for work.
Only 25%. Why so low?
Their thinking, it seems, is that many in that group might be in jobs where, well, daily cabs just aren't financially viable. They'd use buses or maybe bikes.
Okay, so that 25% assumption is doing a lot of work there. 25% of 4 million is 1 million.
1 million people, right age, have the tech, and can potentially afford it.
But do they use it? I mean, even if you can afford it, you might still take the metro or drive your own car or carpool.
Precisely. That's the fourth filter.
Yeah.
Actual usage during that peak time. Just because you can doesn't mean you do.
So what percentage did they estimate actually hails a ride?
The source assumes only 20% of that 1 million group actually opts for a ride-hailing service during that 8 to 11 a.m. window.
Just 20%. Wow. So considering all the other options, yeah?
Yeah, buses, metro, personal vehicles, everything else. So 20% of 1 million, that gives us 200,000.
Okay, so 200,000 people. That number, according to the source's logic, represents the total demand for ride-hailing across all platforms during those 3 peak hours.
That's their estimate for total peak demand, yes.
Yeah.
Now we need to get to Uber specifically.
Right, because the question was about Uber drivers. So market share.
Market share. The source assumes kind of an even split at the top, 40% for Uber, 40% for Ola, and the remaining 20% for smaller players or autos.
Okay, seems like a reasonable guess.
Yeah.
So Uber's share of that demand is 40% of the 200,000.
Which works out to 80,000.
80,000 rides. That's the estimated demand for Uber during that 3-hour peak window, based on this model.
Exactly. So that's the demand side figured out following their steps. Now, how many drivers does it take to meet that demand?
This is where it gets operational. Like, how many rides can one driver actually do? Especially in Bangalore traffic.
Traffic, yes. The source tackles this by estimating ride duration. They start with, say, a normal 20-minute ride.
But peak hours are not normal.
Definitely not. So they estimate that traffic doubles the actual driving time to 40 minutes.
Okay, 40 minutes stuck in the car.
And then they add a buffer, like 5 minutes between rides, for finding the next passenger, waiting, drop off,
Makes sense. So 40 minutes driving plus 5 minutes buffer. That's a 45-minute cycle per ride during peak.
45 minutes total turnaround time per ride. Now, the peak window is 3 hours, which is 180 minutes.
So how many 45-minute rides fit into 180 minutes? 180 divided by 45, that's four rides per driver.
4 rides per driver across that entire 3-hour peak period.
Or if you average it out per hour, 4 rides over 3 hours is like
How?
1.33. No, wait, 4 divided by 3. Hang on.
It's actually simpler to think rides per hour. If a ride takes 45 minutes, or 0.75 hours, then in 1 hour, a driver completes 1 divided by 0.75 rides, which is about 1.33 rides per hour. Wait, let me recheck the source's math. Yeah, the source said 0.75 rides per hour, didn't it? How'd they get that? Maybe it's rides per hour over the whole window? 4 rides in 3 hours? Yeah, 43 is 1.33. Let's reread that bit. Okay, looking back at the source. I see how they framed it. They calculate the total rides needed per hour first. 80,000 rides over 3 hours is about 26,667 rides per hour.
Right, roughly 27,000 rides needed every hour during peak.
And they state the driver capacity as 0.75 rides per driver per hour. Maybe they calculated the 45 months differently or used a different total time window slightly differently. Let's stick with their number for capacity. 0.75 rides per driver per hour.
Okay, so if we need about 26,667 rides per hour and each driver can manage 0.75 rides in that hour.
Then you divide the total need by the individual capacity. So 26,667 divided by 0.75.
Let's see, 26,667.75. That comes out to around 35,556.
Exactly. And the source material then kind of rounds this, presenting the final estimate as approximately 30,000 Uber drivers.
So 30,000, that's the number this specific method lands on for Uber drivers needed during peak hours in Bangalore.
Based purely on their chain of logic, their filters, their assumptions about behavior, affordability, traffic, and market share. Yep, around 30,000.
It's really quite something to see how they took that huge 13 million population figure and just whittled it down step by step.
It really shows the power of breaking down a complex problem, doesn't it? But it also, it really highlights how much depends on those assumptions.
Oh, absolutely. Change that 80% tech penetration, or the 25% affordability, or the 20% usage, or that 45-minute ride time.
Any single one of those changes, and that final 30,000 number could swing wildly. It's entirely dependent on the inputs chosen in the source.
So this specific calculation gets us to their estimate of roughly 30,000 drivers. It's one way, one model.
And that leads perfectly into the final thought for you, the listener. We've just walked through this source's method, heavily reliant on peak demand and these specific assumptions.
So the question for you is, given this approach, what other factors, what variables that weren't included in this particular calculation from the source might significantly influence the actual number of Uber drivers operating in a city like Bangalore? Not just during peak, but overall.
Things beyond just peak demand calculations. What else is in play? Something to think about.